There we go.
Because just as you mentioned that, I was saying to myself, but we are recording it, so it is a little bit of a test. Okay, so then if we move down, I think if the driver is OPEX, then the operator and helper should also be OPEX. Richard, an easy one for you: fuel and truck maintenance. What do you think that is?
OPEX.
OPEX. Okay. Back to Laura. Land value for the office. What do you think that would be?
I feel like that's an indirect CapEx.
Okay, so now we're starting to get very fancy already. So yes, that would probably be an indirect CapEx, and probably the same with the business office, the actual office premises. Office assets would probably fall into that also. And then you can see that there's a bunch of maybe indirect OPEX costs. Things like the disposal license, the support staff, the director, the ops manager, and the office admins, and then taxes and insurance. Okay, so you can see there that from our data sheet, we've got these various costs, and already we've tried to understand, where they could possibly fit in. At the bottom of this data sheet, and then, sorry, associated with all of those data points, you'll see various cost information. So, the cost, there'll be a unit associated with the cost, so US dollars in this instance, and a little bit of notes. As you can see here, the note indicated to us that it's inclusive of import, duty, and taxes. Also, the lifetime of that asset. So a vacuum truck typically has a lifespan of 15 years in this case. And then also the year of purchase. And you can see that for the various vacuum trucks, some are older and some are newer. Okay.
Can I jump in here, Philip?
Yeah.
So just for Laura and Richard and a few people who may be not so familiar with Cactus, this was actually a really important idea that we brought into Cactus. So people often talk about the cost of sanitation, and they confuse the real operational cost of an in situ project with the theoretical cost of what a project is supposed to cost. And they also quite often only count, for example, the capital cost of constructing the asset rather than the operational cost. So one of the principles of Cactus is that we're collecting data from operational systems which are on the ground with all their faults and inefficiencies, because we're really trying to work out what does it really cost when you've built all the stuff and you're running it, rather than, what's the theoretical. So a lot of the data that is used currently to estimate, for example, global cost benefit for sanitation is based on design costs rather than actual. So just wanted to say that that's good, because I think it makes our data more useful for a planning purpose. It's also a problem when we're collecting the data, because as you can see from this is a real set of data we got from somewhere, and it's a mess. People buy trucks at different times, people pay for some things and don't pay for other things. So yeah, just to sort of support what Philip's about to demonstrate, which is then when Imanti and Citywise and our colleagues are collecting this data, you have to work out what all of this means in terms of the sort of useful overall cost data that's going to be used into the future. Sorry, Philip, back to you.
Yeah, sorry, can I ask a quick question? Just because I know that I imagine there were some boundaries drawn around kind of like what would fall into the costing. I don't know if you can tell us a bit more about that. Like, for example, or things like, the personnel for enforcing regulation, things like that included into this, or at the moment, or is that going to be there in the future? No,
that's a really good thing. So the costing is done from the perspective of what we call the archetypal operator. So it's the operator's costs. So in this case, the archetypal operator is actually the same as the actual operator. It's this lady, Mrs. Happiness, and she's running a business. So it's the cost of her business operation that we're interested in. If it was a utility, obviously we have to be a bit smart drawing the boundary around it, but it's not the governance cost. So it's not the regulatory cost, and it's not the cost of housing improvements. It's the cost of the service delivery operation.
Okay.
That's the boundary. And we do have a set of very boring standard definitions for all of the costs which are included. And that's actually why we developed these workbooks that Philip's showing here, because we wanted it to be easy for people to know what to include and what not to include. So if there isn't a cell in the workbook that says regulatory costs, then you know that that's something that isn't included. That's the theory anyway. it's a balance between making it flexible and making it comprehensible. I have to say, it's not trivial as an exercise. Back to you, Philip.
Yeah, so perhaps just to support your question, Laura, and as Barbara has indicated, you can see we now under the direct OPEX tab, and we've got main headings here being salaries, then variable staff payments. So you might have staff that are directly involved on a day-to-day basis, but then you might hire casuals as an example. You can also see non-salary expenses for permanent or long-term staff, things like vaccinations. Now, and the list goes on, as Barbara indicated. Now, we're not anticipating that each system that we're going to go to, that all of these costs are actually going to be valid, or that you're actually going to find data for all of these costs. You might sometimes have that, costs are unfortunately agglomerated and you can't kind of break it down, and you have to make some assumptions from first principles or so forth. So I think what we've tried to do with the list is to try and make it comprehensive, so that as Barbara has indicated, that you can see what you should be thinking about when you're trying to engage with it and trying to find the costs. But if the cost of PPE, personal protective equipment, is captured under another line item, and it's impossible to split it, then we want to capture it anyway within that other line item, because as the idea is to try and find out what is the annualized cost per household or per person to run this service. So I think that's the key thing. So we have to be flexible, because the data is unfortunately for each instance going to be very different. So each business or each utility that you're going to is probably going to capture their financial data in a different manner, and so one has to explore this with them. I'm just going to quickly take us back. We've been talking for 15 minutes. We haven't filled in anything, Barbara. I hope that's okay.
That's okay.
But just at the bottom,
we're not going to throw you out of the project. Okay.
At the bottom of the screen, you'll see just a little bit of context information. So, what we've got over here is all trucks are in operation, average 2 trips a day, 6 days a week. Average is 25 calls per truck per month, mostly servicing residences, so residential containment. Containments are emptied approximately once every 4 years. Received calls from an area of about 400 square kilometers. One truck does an average of about 30 kilometers per day, and the average family size in Cityville is 6 persons per household. So now a typical question is, so how many households or how many people are we actually servicing via our trucks? So this Mrs. Happiness, how many people is she actually servicing? And that's one of the first questions we need to ask ourselves. So we know that we've got 5 trucks. So if we look at the data, 1, 2, 3, 4, and 5, they do an average of 25 calls per month. So 5 times 25 is 125 calls that she can do in a month. And now the question is, how do we turn that into household served? How do we turn that into then population served? Does anybody have any ideas?
Sure.
Go for it, Richard. Don't do the maths in your head, though.
Let me see. So we got 125 calls per month, right? Households served per month. And that is serving, you say, containment every 4 years, right?
Yep.
So that would be 125 times, let's say, 4 in order to get to annualize it, I think, right?
Mm-hmm. Yeah.
So that comes out to 500, right? And each household has, I don't know, let's say average 5 people.
Mm-hmm.
So 500 times 5 people is 2,500, Is that right? 500 times 5. Yeah, 2,500 people. Is that right?
So it's not right, but
It's not right.
your thinking is on the right path. So
Okay.
if we are able to do 125 per month, how many can we do in 1 year?
Yeah, that's the only thing you missed out, Richard. You missed out the months to years. Everything
Oh, yeah.
else was bang on.
Yeah.
Sorry.
No, I'm really impressed you had a shot at that. That's really good.
So if we do, so basically it's you as Barbara's indicated, you are right. It's just basically that we're doing it, times by the 12 months, and then times by what is quite tricky for some people to understand is that when do we serve all of our population, all of our community? We serve them once every 4 years. So our total population must then be multiplied by the 4 to try and get that number. So in essence, what we would do is we would go here to our sheet and we would say in terms of our number of households served, it would be equal to our 5 multiplied by 25 multiplied by 12 and then multiplied by 4. And that would give us a value of 6,000. And then we would need to write some explanation here because of the fact that in a year's time, when we come back and say, how did we do this calculation? This will actually help us then. Okay. Now, at the bottom of the sheet, you'll see there that the average family size is 6 persons per household. So obviously then in terms of the number of people, that would be 6. And then in terms of the number of people that we serve, that's quite simply 6,000 multiplied then by the 6. Okay.
Interesting, actually, this kind of numbers of people served problem is one of the really tricky ones when we share the data and when we're talking to people at local level about this data, sort of getting operators, but particularly policymakers, to think about who's covered. It's the same with sewerage, getting people to think about the difference between how many people are actually connected to our system and what was the original theoretical capacity of the system. And we're always, as I say, trying to look at the actual serviced community, not the theoretical maximum service community, because we're recognizing that most systems don't run at full efficiency. So these trucks maybe are supposed to do more than 25 trips a month or whatever it is, but if that's what they're doing, that's what they're doing, that's what we go for.
Okay. All right, so we're just going to move swiftly along. You can see that there's a number of questions here around the containment technologies and so forth. How many residential households do you typically serve in 1 month? We know now that that's 25 times by the 5, so that's 125, and we would just fill that in on the sheet. After how many months do you go back? We know it's every 4 years. What is the geographic area that you serve? We know that that's 400 square kilometers. That's this one over here, 400 square kilometers. And then how far are the toilets you empty typically located from the disposal point in kilometers? And we know that they told us that one truck does an average of 30 kilometers per day. So we would put in the 30 kilometers over here as an example. Okay. All right, so that's just some context information. With your permission, I'm going to jump into one of the actual worksheets to see if we can fill this in. So the first item you see here is around vacuum trucks, and we've got quite a bit of information here on our 5 vacuum trucks. So a quick question, what is the cost of the vacuum trucks? Anybody want to hazard a guess as to how we would work that out?
Go out and buy one.
That's a really good, yeah.
Okay, so quite simply, if we took the $30,000 plus the $20,000 plus the $18,000, the $15,000 and the $14,000, we add those together, then we would get our cost. So we would just do that maths quickly here, plus 20,000.
50, 68.
Plus 18. You're doing it.
Oh, he's doing it old style.
I'm much better at old style than typing in anyway and trying to talk at the same time. Some of us just,
I want Richard in my class. I tell you now, he's going to be amazing.
Okay, so now you can see here that we have put it as 97,000, but now because this was done within Zambia, you know, the template has been set up for kwachas in Zambia, but now we have to change it because our unit here is USD. Okay, so you can see that there's a default that refers to our contact sheet and basically shows, you know, the kwacha. But we have to then go and change the currency. Now, what you'll see here is also there's a confidence in our cost estimate. And that might be a little bit small for you guys to see, but it ranges from 0%, you know, plus minus 0%, which means that you know that this is the exact cost, versus all the way down, it's 100%. So basically, complete thumbsuck. We've got zero confidence in this number. So if I had to ask you for these vacuum trucks, what would you say your confidence would be? What would your guess be?
You said it's 0%. You have zero confidence or zero error?
Zero error, yeah. You completely confident.
I see.
And sometimes people don't know, but sometimes, yeah. Sorry, go for it.
50%.
Was that you, Musa?
Yes.
What do you think the confidence would be?
I think it will be 50%.
50%.
Yes.
Okay, so if this vacuum truck operator showed you the invoice or told you this is what I paid for it, I paid $30,000 for this vacuum truck, would you say that it's plus minus 50%? Or if you know, you might say then that maybe it's at plus minus 0% because this is the exact cost that that person paid for that truck. However, Musa, you're 100% right. If the person says, I can't quite remember, oh, it was so long ago, I can't find those records. Are you from the tax authority? Because I don't really want to tell you what it actually cost, you know, and they start making excuses. Then we need to, in terms of that confidence level, we need to move up, and then we might hit something like a 50%. So in this instance, yep.
Sorry, because it's an aggregate of all the trucks, and it may be that you have some confidence in some and less confidence in others, but I'm also noticing that there are different dates of purchase. Like,
yes,
is this just you're doing your best guess to come up with like what you feel it should be, like plus or minus, you know, 10% across all of them, or is there something? Are you looking for something more accurate?
You need to be a little bit quick because we have to go back to the main room.
Okay.
So just wanna,
all right.
Yeah.
So just quickly, it's a great question, and yes, so there has to be some kind of judgment. I always like going back to first principles so that I can justify how I got to a decision. So, you know, you might find that of the 5 trucks, 4 of them, they are very confident in the costs, but one of them, they weren't, you know, it's a bit of a thumbsuck. Then you might say, okay, well, maybe I need to go to plus minus 5% or plus minus 10%. That could be a gut feel thing. More accurate would be if you do some maths on it. And that's exactly what happens as an example. So let's say for this example, we were 100% confident with the actual costs. The lifetime, if you look at the data sheet, all of them are 15 years, but you are 100% right that in terms of the year purchased, what do I put in there? Do I put in 2013? Do I put in 2017? And yeah, what one can do is have like using a rounding function to say that, you know, if I take $30,000, let's say that as an example, multiplied by 2017 being the year, and I do that the same with the $20,000 for vacuum truck number 2, multiply that by the year of 2016, and I carry on for the 5 trucks like that. I divide that by the total cost, which is this $97,000. And then I round it up, you know, to the nearest year. I will then get an average year for all of my trucks. So that would be a way of doing that. Barbara, do we only have 1 minute left?
We literally have to go back. So I think we should stop with the sheet now. But just to summarize what Philip's kind of demonstrating, and Laura, you're touching on here, is that we were trying to design a tool that would allow us to have these conversations with service providers and people giving us information. And we want to stack all this data into the database, but still be able to spit out at the end some usable planning data, which I'm going to talk about in plenary. So I don't know if you've got a feel for it, but it's a little bit of a constant sort of balance between, oh, we don't want to be super accurate because we never collect any data at all, but we need, as you kind of hinting, you know, some context. I think we should go back to the main room. To do that, what we need to do is leave this room, close this meeting, and go to back to the plenary meeting on the main website. Haroon, are you waving or asking a question?
Oh, sorry, I was saying bye.
Cool, bye. We'll see you all back in the main room.
By the way, happy belated birthday to all these August people.
Oh yeah, good shout.
Awesome. See you guys soon.